Hi, Remy here, and in this video I'll be installing the FilGuard Filament Runout sensor from Mello. So this will be installed on the VZBot Hextruder, and this is the VZ Plus model. So let's unbox. So you have the actual filament runout sensor and the filament motion sensor and the supporting item. So let's remove the sensor. So you have the header pins. This is 2.0 mm pitch, then two M2 screws and one M3 screw, and then the housing for the connectors, and you have the actual sensor. This is the actual sensor. You have a button over here. So this will be the bottom side. So you need to install this like this on the bottom side, and this will go on top this way. So this is how you do the installation, and then we have to install the two screws over here. So this is how you do the installation. Please note that there are no wiring supplied with this. We need to source the wires, required wire, and do the termination ourselves. So I will complete this and be back. So now I have connected the sensor. The wires also are connected to the toolhead board. Next, I need to install or mount the sensor to the hextruder. For that, I need to remove the coupling, the board and tube, and this connector. For that, I need to unscrew over here. There is a grub screw over here that I need to remove, and I'll mount this. So I'll do that and be back. Now the sensor is mounted on the hextruder, and this is the board and connector and the grub screw. So keep this safe, you might need it later. Please note, the last one, this terminal is empty, the cable is not connected. This is for the button pin, which is located here. So the button pin is here. So this I have not connected to the toolhead board because there is no general purpose input pin available on the toolhead board. I had to remove the sensor. That is because if you try to install the filament via the sensor like this way, what happens is the filament does not go inside. You need to fiddle around to make sure that the filament is right at the center. If you see this thing, there's a wider hole, then the hole becomes small, and then you have this thing outside. Similarly, down here also it's like that. So if the filament, if you try to put it inside, sometimes it goes at an angle and it stops on that thing that is outside. So like this. So just think that this is that bottom part. So instead of going at the center, it will go outside on top of this, and it will stop going inside. So you need to fiddle around to make sure it is right at the center to go inside. So for that, what I had to do is I cut this PTFE tube. This is 7.5 mm in length. So I need to install this in between this way. So now it guides the filament to the center, and then it will go inside. Then you can install the sensor. Now let's look at the pinout. So from right to left, 5V ground, then the filament runout switch. This is the motion switch and the button. This is the button over here. So for that, this is the pin. Now let's look at the wiring diagram. The diagram shown over here. This is the example to connect the orbiter filament sensor, but I'll be using the same pinout to connect the FilGuard sensor. So to connect that, I'll be using the 5V connected to this pin, ground connected to this pin, then filament sensor that will be connected to the end stop header pin, which is here for this, which is GPIO 20, and the filament motion sensor will be connected to the BL touch header pin to GPIO 22, which is this pin. You also need to install a jumper over here, that is to set the voltage as 3.3 volt. Please note that the button pin I'm not connecting over here because the toolhead board I do not not have any other additional general purpose input pin. So I'll have to sacrifice the end stop, this pin, and for that I'll have to move to sensorless homing. Only then I'll be able to connect the button pin to the toolhead board. Other option is to wire this directly onto the main board of the printer. So for now I will leave it as it is. So I will not use the button pin. So this will be left empty. This is the model that I ordered from AliExpress. So this is the VZ Plus version. You have the normal version as well. And you also get just the hardware. So the bracket, you will have to print it yourself. Link for the STL is down in AliExpress listing itself. So which is here. So from here, you'll have to download this and print the required version that you need. Now let's look at the macros. All the macros related to filament runout or filament motion sensors are defined in FilGuard.cfg file, and this file is included in the printer.cfg file. First, we'll look at the motion sensor. Pause on runout, this is set to false. Switch pin, the pin where this motion sensor is connected to. Extruder, where this motion sensor is associated to. Detection length, that is the amount of filament must move, or there must be a motion, otherwise the motion sensor will be triggered. That is, if there is no movement, the filament is not moving a minimum of 2 mm, this motion sensor will be triggered. This is the default value as per Mello. This value works fine for me. You might have to tune it, increase it as per your requirement. Event delay is to avoid any trigger of filament motion within 3 seconds. So if there are too many triggers of motion sensor within 3 seconds, those will be avoided. Runout G-code. So the runout G-code will be executed once the motion sensor is triggered. This will pause the printer only if it is printing. This is required to avoid unnecessary triggers during maintenance mode. In insert G-code, if the printer is not paused or not printing, it will heat the nozzle at the desired temperature. Here it is 240. And then after heating the nozzle, it will extrude a 20 mm of filament at a very slow rate. Next, we have pause after delay macros. This macros I took from a Reddit user. Link will be in the description. Next, we have delay G-code macro. This macro is to disable the filament motion sensor when Klipper starts. This is required in order to avoid unwanted triggers during maintenance mode. Now let's look at the filament runout sensor. In this, pause on runout is set to false. This is required in order for the pause at delay or pause at distance feature to be working. If this is set to true, as soon as the filament runout sensor is triggered, the printer will pause. It will not wait for a distance, or it will not delay the pause. It will immediately pause the printer. Switch pin, where the runout pin is connected to. Event delay, event triggers during this period will be silently ignored. I have reduced this value to 1. Default is I think 3. In runout G-code, it is important to disable the filament motion sensor as the very first step. If you don't do this, then the motion sensor will also be triggered. So you'll have double triggering, one for runout sensor and one for motion sensor. And when that happens, the pause at delay or pause at distance feature will not work. The printer will pause immediately. So this is required in order to have the pause at distance feature working. If you don't want, then this line can be removed. The next is the pause at distance. So pause a 45 mm of filament while it is printing. So if it is printing and detects, only then pause at 45 mm of distance. This distance is the distance between the filament runout sensor and your extruder gear. In insert G-code, the very first step is to re-enable the filament motion sensor, as this was disabled at the runout over here, and the remaining code remains the same as filament motion sensor insert G-code. Now let's see the sensor in action. We can use this LED to get the status of the sensor. If it's orange, meaning no motion, there's no movement of the filament. If it's red, then the switch sensor is triggered, that is filament runout sensor. If it's green, meaning it is retracting or unloading of filament. If it's blue, then blue has two states: slow blinking, meaning movement of filament is slow. If it's fast blinking or steady on, the filament is moving fast. Now the test print will start. Please note, the filament motion sensor is in disable state at the beginning of the start underscore print macro, and it will finish the prime nozzle cleaning of the nozzle, and just before the print start, it will enable the filament motion sensor. So the print is started now. So let me try and trigger filament motion sensor. So I'm holding the filament in my hand and the filament motion sensor is triggered. I'll resume the print now. And here I can see a gap, that is because of the motion sensor trigger. So it was not able to extrude 2 mm of filament. And now I will cut the filament to trigger the filament runout sensor. When I cut the filament runout sensor should trigger, not the motion sensor. So the red light should blink. And it should still continue to print for about 45 mm of filament. So the filament runout sensor has triggered, but it is still continuing to print for around 45 mm of filament, and then it should pause. It has paused now. I inserted the filament, and please note that it has auto started to extrude. The blue light indicates that it is inserting the filament. And once this has stopped, I have to go and resume it. So now I'll resume the print, and it should go and start to print. There will be a gap because that I need to fine tune the value. So as you can see, there is a gap of 45 mm. Due to the 45 mm of distance trigger, the gap is there. This I need to reduce the gap. I need to fine tune it, but the concept should be clear here. So it still continued to print even though the filament ran out for about 45 mm of filament distance. So this will continue. Next, I will show how the filament runout sensor and the motion runout sensor will trigger if we do not disable the motion runout sensor as soon as the filament runout sensor is triggered. So in that case, you will not have the pause at a distance triggered. So let me show that now. So this is the print of the first tag. I stopped it here. So this first gap is due to the motion runout sensor, and the second one is due to the filament runout sensor. So this has a wider gap. I need to adjust the runout distance that I need to reduce. Now in the filament runout sensor, I will disable this line, which actually disables the filament motion sensor. So once you disable this, the filament motion sensor will also get triggered as soon as the runout sensor is triggered, and that way it will not wait for the pause after distance wait time. So it will immediately trigger the motion sensor and pause the print. So save and restart. And I'll start the same print. Now the test print is going to start. Please note that the filament motion sensor is in disable state. So this is disabled at the beginning of the start underscore print macro, and it will finish the prime nozzle cleanup, and just before starting the print, it will re-enable this the filament motion sensor. So the print has started now, and the filament motion sensor is enabled and it's detected. So let me once again try and trigger the motion sensor by holding the filament. So I'll loosen this gap so it doesn't put too much pressure while holding the filament. And now I will hold the filament. This should trigger the motion sensor. So the motion sensor has triggered. And now let me resume. And now I will cut the filament. Please note this time the motion sensor won't be disabled as soon as the runout sensor is triggered. So what will happen is, as soon as I cut the filament, the runout sensor and the motion sensor will be triggered, and it will not pause for the extended amount of filament delay. That is, it will not wait for 45 mm of filament. So let me cut this. Now both the filament motion and the filament runout sensor should trigger. Actually, filament runout is there. So if you see now, lack of filament is triggered and also blocking material is triggered. In the previous case, when I was holding the filament with my hand, only blocking was triggered. Now this time, lack of filament triggered, that is at the filament runout sensor, and also blocking material triggered. So that's all for this video. I hope it was helpful to understand how to make use of filament switch sensor and the motion sensor. If you like this video, do like, share and subscribe. God bless and stay safe.